Okay, I'm gonna try to go through this study guide quickly, so you're probably gonna have to pause the video at times so you have time to write and just kind of process everything. But I don't want the video to be super long because I have a feeling it might be, so I'm just gonna try to rush through this. All right, identify the characteristics of a quadratic function and its graph. Okay, so let's start with the vertex. Looking at the vertex is right here, and that is the point 4, -2, no, 4 positive 2. Whoops, sorry, off to a great start. Okay, axis of symmetry goes through that x value of 4, so x equals 4. Domain is all real numbers because it's going forever this way and forever that way. So all real numbers. Range, your lowest y value is 2, and then all of the y values are up from there. So it's y is greater than or equal to 2. End behavior, as x is approaching infinity, so as I am going this way on the graph, my y values are going up. The end of my graph is going up to positive infinity. If I am going this way on my graph, the end of my graph is going up, positive infinity. Okay, it is increasing. So this is where you want to think about the little guy coming in from the left-hand side. Okay, this is where he would be going down. So this is the decreasing part. So it's decreasing on this side of the parabola. It's decreasing on this side of the parabola. So it's decreasing when x is less than 4. And it's increasing, because once he gets here, he's going to start increasing here. So it's increasing when x is greater than 4. You basically just take your x value of your vertex, and there's a greater than and a less than one. It's going to flip, though. It's going to be opposite if it's a downwards parabola. Okay, create a table of values to graph f of x equals 2x squared. So let's do -2, -1, 0, 1, 2. All right. -2 squared is 4 times 2 is 8. -1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Plot your points. -2 up to 1, 2, 3, 4, 5, 6, 7, 8. -1, 2, 0, 0, 1, 2, and 2, 8. Okay. Next one, create a table of values. So we're going to do -2, -1, 0, 1, 2 again. All right. -2 squared is 4 times -2 is -8. -8 plus 1 is -7. -1 squared is 1 times -2 is -2. -2 plus 1 is -1. 0 times anything is 0, plus 1 is 1. 1 squared is 1 times -2 is -2, plus 1 is -1. And 2 squared is 4 times -2 is -8, plus 1 is -7. Plot your points. -2, -1, 2, 3, 4, 5, 6, 7. -1, -1. 0, 1. 1, -1. 2, 1, 2, 3, 4, 5, 6, 7. It's a downwards parabola, which makes sense because this is a minus sign in the front. Okay, next. Graph f of x equals -3x squared minus 12x minus 11 by finding the vertex and the y-intercept. Okay, so to find the vertex, we're going to use x equals -b over 2a. And looking at this, we could see that a is -3 and b is -12. So just be careful with your negatives here. X equals -b, so positive 12 over 2 times a, which is -3. So that's x equals 12 over -6, which is x equals -2. We're going to plug this value back in to find our y value of our vertex. So f of -2 equals -3 times -2 squared minus 12 times -2 minus 11. F of -2 equals 4 times -3 is -12. That's a plus 24 minus 11. -12 plus 24 is 12 plus, minus 11 is 1. So f of -2 is 1. So that is the vertex -2, +1. Okay, -2, +1, plot that. We can also plot our y-intercept. Our y-intercept is always our c value, which is -11. So -11 is going to be down here. This is -10. -11 is just a little bit beyond that. So it goes off your graph. Okay, so it's going to look like this on this side, and then it's got to be symmetrical on the other side. So you know that your other point is going to be over here. Just draw it symmetrically. Something like that. Okay, next one, graph f of x equals -x minus 4 squared minus 1. So with this is in vertex form, and we can just use our shifts. This is shifted right 4, down 1, right 1, 2, 3, 4, down 1. And it's a downwards parabola, right, because of this minus sign. So we're going to go down 1 over 1 on both sides, down 1, 2, 3 over 1. And then if you want to go down 1, 2, 3, 4, 5 over 1, you can do that as well. Okay. Let f of x equal -2x squared plus 2 and g of x equals 4x minus 4. Describe the transformation from the graph of f to the graph of g. Okay, so basically what this minus 4 is doing is it's shifting, the graph down 4 units. So it was shifted down 4 units. And then part B just asks you to write the equation that represents g in terms of x. So that just means write the new equation with the -4 in it. So you're taking g of x equals, you're going to plug in f of x, which was -2x squared plus 2. Okay, we're plugging in f of x there, right? And then there's a -4 here. So g of x equals -2x squared. 2 minus 4 is -2. Okay, number 7 through 9 are multiple choice, and you're just describing the shifts from the parent function, f of x equals x squared. So this is shifted right 4, right, opposite of what's inside, and then up 1. So which one says right 4? Oh my gosh, right 3, not right 4, sorry. Which one says right 3? Up 1, right 3, up 1, this one, C. Okay, this one, there's a few things that are happening. This -2 means it's shifted down 2 units. This negative is flipped over the x-axis, and the 6 is a vertical stretch by a scale factor of 6. So we have to look at what says all of those things. Reflected over the x-axis, yes. Vertical stretch by a scale factor of 6, yes. Shifted down 2 units, it is A. Okay, this is shifting it right 2 units, and it's a vertical compression by a scale factor of 1/3. So this says vertical compression of scale factor of 1/3, shifted left 2 units. No, it's not right because it's shifted right 2 units. Vertical compression by a scale factor of 1/3, shifted right 2 units. It is B. Okay, this one says write a quadratic function in vertex form whose graph has vertex -4, 2 and passes through -5, -7. So you have to use vertex form, which is f of x equals a times x minus h all squared plus k. So f of x equals a. We know our vertex is -4, 2, so that goes in the hk part. But it's negative already, so -4 is a +4, so x plus 4 squared, and then plus 2. Now I'm going to plug in this other point. This is x and this is y. And remember, f of x is actually y. So the -7 is going in here. The -5 is going here, in for x. And we're just going to simplify everything now. So -5 plus 4 is -1. And -1 squared is just 1. And 1 times a is just a. And then I'm just going to subtract the 2 over. And that gives me a equals -9. So in vertex form, it is f of x equals, I plug in a -9 here. That's my a. X minus h, but remember it's actually plus 4 squared, and then plus 2. Okay. Number 11, calculate the rate of change of each function from x equals 2 to x equals 4. Which function's growing faster? Okay, so x equals 2 to x equals 4. In the table, I'm just going to circle those points. X equals 2, x equals 4. So those are the points 2, 1, and 4, 2. And we're going to find the slope because average rate of change really just means slope. So we're going to do 2 minus 1 over 4 minus 2, which equals 1 over 2. So the slope of that is 1/2. Now the slope of this one, x equals 2. You're going to go to x equals 2 on your graph, go up, you hit the graph here. So that's a point. That's the point 2, 2. Then go to x equals 4 on your graph, go up until you hit a point, hit the graph, and that's 4, 8. Find the slope, 8 minus 2 over 4 minus 2, which is 6 over 2, which is 3. Okay, so those are the average rates of change, the slopes, and the one that is growing faster is function B, because that's a greater number, 3. Sorry, moving the paper out of the frame. Okay. An object falls from a height of 256 feet. What does the function h of t equals -16t squared plus 256 represent in this situation? Okay, so what it represents is, you don't have to write this word for word, just the gist of it. So it represents the height in feet of a falling object t seconds after it is dropped from an initial height of 256 feet. Okay. After how many seconds does the object hit the ground? So ground is 0. Ground level is 0. So we're going to set this function equal to 0. And we can actually factor out a -16. Have to factor out the negative. If we factor out a -16, we're left with t squared minus 16, because 16 times 16 is 256. This is the difference of two squares. This factors to a plus b, a minus b, so that's t plus 4, t minus 4. And then if you set all of these things equal to 0, this doesn't mean anything. T equals -4 would make no sense, so it's t equals +4 seconds. Rewrite the quadratic function in vertex form. So this is in standard form. We're converting it to vertex form. We're going to do that by using x equals -b over 2a. So x equals, well, a is 4 and b is -8. So -b actually would be +8 over 2 times 4. So it's 8 over 8. So x equals 1. Plug back in to find out what your y value is. So y equals 4 times 1 squared minus 8 times 1 plus 5. 1 squared is 1 times 4 is 4 minus 8 plus 5. So that's negative 4 plus 5, which is 1. Okay, so vertex form. So first of all, our vertex is 1, 1. Where should I write this? My vertex is 1, 1. Vertex form is f of x equals a times x minus h all squared plus k. We know that a is 4. So put a 4 in there. X minus your h value is your x value really of your vertex, which is 1, plus your y value of your vertex, which was also 1. There's your vertex form. Okay, a beanbag is tossed into the air. The function h of t equals negative 5t squared plus 5t plus 1 represents the height in meters of the beanbag after t seconds. What is the maximum height of the beanbag? Okay, maximum height, we're going to use negative b over 2a, and we're going to find our y value in the end. Okay, so a is negative 5 and b is 5. So negative b is negative 5 over 2 times a, which is negative 5. So that's negative 5 over negative 10, which is going to reduce to 1/2. So it's going to be probably a little bit messy. So h of 1/2 equals negative 5 times 1/2 squared plus 5 times 1/2 plus 1. So that's negative 5. 1/2 times 1/2, if you want to do side work for that, you can, but you should know that that's 1/4. So negative 5 times 1/4 is negative 5/4, plus, that's really 5/2, plus 1. Okay, simplifying down. Common denominator of 4 here, so let's do negative 5/4 plus, to make that a 4, I'm making that a 10. And then this is going to be 4/4. Negative 5 plus 10 is 5, plus 4 is 9. So 9/4 meters, which you can write as 2 1/4 if that makes more sense. That is your maximum height. Okay, next, write a quadratic function in standard form that passes through all of these points. Okay, so we're going to use kind of like a factored version here. These are our zeros. This is a 0, and this is a 0. So what that means, we have to have our a value in the front, and it's going to factor to x minus negative 4, which is really x plus 4, and x minus 3, because those are our zeros. Then what we're going to do is we're going to plug in our point. So this is your x value and this is your y value. Y value goes in for f of x. So negative 18 equals a times, we're going to plug in 2 here and 2 here and just simplify down. This becomes a 6. 2 minus 3 is negative 1. This is negative 6a. Divide by negative 6, and we'll get a equals 3. And what we have to do here, so we're just going to put the 3 in here. So right now it looks like this. F of x equals 3 times x plus 4, and then x minus 3. But it wanted it in standard form, so we have to actually FOIL all of this out. So let's FOIL this out. So that would be, we're going to keep the 3 in the front for now. X squared plus 3x. Actually, that was a minus 3x, because that's a minus sign. Minus 3x plus 4x minus 12. I'm running out of room. Okay, f of x equals 3 times x squared. Negative 3x plus 4x is x, and then that's a minus 12. Distribute the 3 all the way through, so that's 3x squared plus 3x, and then minus 36. Okay? All right, use the zeros to graph f of x equals negative x cubed minus 6x squared plus 5x. Okay, so what we're going to do is we're going to factor out a GCF here, which is x. So if I factor out an x, I am left with x squared minus 6x plus 5. And then I can factor this further. I want to think what multiplies to 5 and adds to negative 6. So that's going to be a negative 5 and a negative 1. So now my zeros are x equals 0, x equals positive 1, right? Add the 1 over, and x equals positive 5. So you're going to plot those 0, 1, and 1, 2, 3, 4, 5. So basically it's going to end up making like an S shape. You just have to figure out, does it go like this or does it go like this? Okay. How we're going to figure that out is let's just plot like one more point. Why don't we figure out what happens in between here? 1, 2. So let's figure out what's happening at 4. Let's figure out what's happening at 4. So I'm just picking 4. And I'm going to plug it in. 4 cubed minus 6 times 4 squared plus 5 times 4. So f of 4 equals, that's 64. 4 squared is 16 times negative 6 is negative 96 plus 20. 64 minus 96 is negative 32 plus 20. And that's negative 12. So 4, negative 12 is on our graph. So 4, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is on our graph. So it's going to end up going like this. Okay, so if it goes like that, then it goes like that, and then it goes like that. How high up it goes here, you can figure that out if you want to, but I'm not going to make you do that. Just pick one point, and that's fine. All right, tell whether each table of values represents a linear, exponential, or quadratic. So linear is going to have that constant rate of change. So if we look at our rate of change here, this is going to be plus 1, plus 1, plus 1, plus 1. And this is plus 0.5, plus 0.5, plus 0.5, and plus 0.5. So that is definitely linear. Exponential, you're going to see like a really large increase and you're going to be multiplying by a common ratio. So that's, I think that's going to be this one, times 3, right? Times 3, times 3. See how it's going like big numbers really fast? That's exponential. Which means this one must be quadratic. This is those like second differences, but an easy way is you could honestly just look at it and see how it's like symmetrical on both sides. When x is negative 2 and when x is positive 2, you have 4s here, negative 1, 1, 0, 0. But if you do this, the differences, it would be minus 3, minus 1, plus 1, plus 3. And then you would do the second differences. So from negative 3 to negative 1, you're adding 2. And then you're adding 2 in between here, and you're adding 2 in between here. So if the second differences are the same, it's quadratic. All right, almost there. Number 18, the graph of g of x equals ax squared opens upward and is wider than the graph of f of x equals x squared. Which of the following could be the value of a? Okay, so if it's wider, that means it has to be either a fraction or a decimal. So we can automatically eliminate this one and this one because they're not fractions or decimals. And if it's opening upward, it can't be negative, right? So that eliminates that. So it must be D. True or false, given the functions g of x equals negative 1/3 x squared and f of x equals x squared, the function g is narrower than f. Okay, so this 1/3 is really going to make it wider. So that would be, because that's a compression, so this would be false. True or false? The function f of x equals 2x squared is an even function. That is true because it is symmetrical in relation to the y-axis. It's going to look the same on both sides if you were to graph it. So odd functions are not symmetrical in relation to the y-axis, but even functions are. Okay, that is it.